Hello everyone, now we're going to see about error control and error detection in data link layer. Data link layer is the second layer of OSI model and it is considered to be the most complex layer of OSI model. It is responsible for node-to-node data transmission and it also ensures error-free transmission of data. Here we can see that from network layer the data is transmitted as packets and from data link layer it is transmitted to physical layer as frames. There are 5 major functions in data link layer. They are framing, addressing, error control, flow control and access control. Error control is a process of detecting and correcting the corrupted data. It uses a technique called as automatic repeat request, which is used to detect the error and take actions for retransmission. There are certain protocols followed for error control which are listed over here: stop and wait ARQ, go back NARQ and selective repeat ARQ. There are three phases in error control, which are detection of error, acknowledgement and retransmission. In acknowledgement it can be either positive or negative. So the mechanisms followed for error control are majorly two, which are forward error control and backward error control. Forward error control, it is a type of error control mechanism where an additional redundant information is added along with the useful data. So only one additional redundant information is added with entire data, and this additional bit is used for error detection but not for error correction. When the data received is detected with the error, then the error can also be located. So this error control mechanism is not widely used. Backward error control mechanism. In this mechanism, an additional information is added along with each character. It is also used only for the error detection, and it is also called as feedback error control mechanism. When the receiver detects the data with the error, then entire data should be retransmitted. Error detection techniques. There are many detection techniques used, but we are going to see only about parity method and checksum. And parity method, in this parity method an extra bit is added before the transmission. So in the center side an extra bit is added. It can be either 0 or 1 according to the number of ones present. This parity check is divided into two types, which are even parity check and odd parity check. Here the data to be sent is 1001101. Here the number of ones are 4. For even parity check, then 0 is added, as the number of ones are 4, it is even, so 0 is added. And odd parity check, the number of ones are even, so 1 is added. Here at the receiver end, there are three cases where the first one is that there is no error, as the number of ones are 4 and the parity bit is also 0, so it is considered to be no error. When there is an error occurred and the parity bit is still 0, so in the second case we have 5 bits as 1 and the parity bit is 0 and we are using even parity check, so there is an error has been detected. And the third case, when there is multiple bits have been interchanged and the number of ones will always remain the same, so there is a failure to detect error. So these are the three cases at the receiver end. Now we are going to see about checksum, which is used for higher order layer, and this also we will talk using example. Now a 32 bit should be sent. So this 32 bit is divided into 4, which are like 8 bits each, and there are 4 frames. So here at the sender end we are adding first 2 frames, and the partial sum, there is a carrier, so we are adding it again, and the final sum is the sum number 1 is obtained, and with the sum number 1 we are adding the frame 3, again the same repetition of steps. Finally we are getting the sum. For this sum we are complementing it and we are getting the checksum. This checksum is sent along with this 32 bit data. So at the receiver end this checksum is kept aside, and again the same process is done as in the transmitter side. Finally we are getting a sum, and with that sum we are adding this checksum which has been transmitted along with the data. This when the checksum is added we are getting a final sum. That final sum is complemented. When the final sum is complemented and all the bits are 0, then there is no error detected, and if there is any changes other than zeros, then error has been detected. So this is a checksum model, and there we come to the end of the error control and error detection presentation. Thank you so much.